Hello! In this new tutorial we're going to see how to rig a cartoony character using squash and stretch, which is when a limb tries to reach further than its original length. We're going to see in Maya how to set up the skeletal mesh so squash and stretch works well in the game engine. We're going to add a length multiplier so the animator can cheat and exaggerate the effect even more. And we're going to see how to do that on an arm, which would be the same technique for legs, but also for the chest, which would be the same technique used on the neck. For squash and stretch to work in a video game engine, though, there are some prerequisites in how your skeletal mesh is set up. So let's look at how I created my skeletal hierarchy in Maya. Would be the same in any other DCC. So I'm going to show you the entire hierarchy here. So traditionally you start with the root bone, and then you have pelvis, and then you have the thigh, to which the calf is parented, and the foot and the ball. So you have just a regular leg here. And for the spine, there is spine 01, spine 02, spine 03. So all those are parented to each other. And then neck 1, neck 2, head. And then for the arms, you have clavicle and upper arm parented directly under clavicle, lower arm parented to upper arm directly, and hand parented to lower arm. So that's a regular, I would say, game rig. And on top of that, we have all those leaf joints that you can see. And I've made all of them with this sort of green-blue color to differentiate from the purple base rig. So if I take them out of the hierarchy like that, so you can see spine 3, 2, 1, pelvis, and then here on the limb, foot, calf, thigh. And every time we have those leaf joints. So for a thigh or for the upper arm, it's kind of like your twist bones. So if you have twist bones already, you can keep them. And very important is, the lower arm is a direct child of upper arm. It's not like a lower arm is a child of twist 3 over there, which would be a child of twist 2. We don't want to do that. The twists are siblings. They are like in derivation, if you will, not in series, if you compare to like an electric circuit. So they are all parented directly to upper arm. Here, all the lower arm leaf are parented directly to lower arm. So I call them leaf joints just because they are leaves from the tree, but you can't call them a twist. The difference with a twist is that I added a leaf joint exactly on the lower arm and exactly on the upper arm. I mean, for the upper arm, that's traditionally how you would set it up anyway. You would skin the shoulder region onto that first twist joint so it can, counter the upper arm's rotation. So you can refer to the twist bone video for that. But for lower arm, usually you skin the elbow region on the lower arm directly, and then you skin the further you go along the lower arm. So the closer you get to the wrist, you skin the regions to the different twists. So here, the very important thing is to have an extra leaf joint exactly on the lower arm, because we're going to skin our mesh to those leaf joints rather than the, let's say, structural joints, the main joint in purple, like the default color on my viewport. Why? Well, it's because as we're going to scale the mesh non-uniformly, we want to scale independent joints. We don't want to scale joints that are parented to each other. So if I do, let's say, preserve children here, so I scale this joint, and the world space scaling of the hand is preserved. So as this scale of lower arm is increased to, I don't know, let's say 2, it means the hand to stay at what seems to be a scale of 1, it is actually doing a scale of 0.4. So the child of lower arm is countering the scale of its parent to maintain its scaling. And that is something that game engines don't really like in general, counter scaling to preserve their original scale. So that's why we only scale independent joints, leaf joints, and not joints that are inserted in a hierarchy. So you don't want to scale lower arm because it has a child hand. You only want to scale joints that are independent like that. So in this example, I would actually never scale lower arm. I would leave it at 1, and I would only scale the leaf joints. Okay, so same on the thigh. So same for the leg. We have a joint called calf leaf 01 here, exactly placed on the calf. And for the spine, similarly, we have leaf joints for every spine bone. So there's spine 03 directly parented to spine 03, spine 02 leaf directly parented to spine 02, and spine 01 leaf parented to spine 01. And same for the neck if you want to be able to scale the neck. So that's the hierarchy you want at the end of the day. Now, this may not be the best to do your initial skinning pass because my skinning algorithm won't understand really well how to distribute the weights by default if you are trying to just skin joints that are not direct children to each other. So in this case, I would temporarily break the hierarchy I've just showed to be able to skin more easily. So I would take spine 03 leaf and parent it to spine 02, take spine 02 and parent it to spine 01. Okay, basically do the wrong hierarchy, the one where all the skin joints are in series, so they are children of each other. I would parent the clavicles to spine 03 leaf. For the neck, I will parent head leaf to neck 02, neck 02 to neck 01 leaf, neck 01 leaf to spine 03 leaf. All right. For the arms, I'm going to do hand parented to lower arm leaf 3, and so on. Leaf 03 to leaf 02, 02 to 01. Then lower arm leaf 01 parented to upper arm leaf 03, and then 202 and then 201. Okay, and then same thing for the other side. So every time I press P in my app to reparent, I can also do middle mouse button click and drag. And then for the leg, so foot parented to calf leaf 02, calf leaf 02 to leaf 01, calf leaf 01 to thigh leaf 02, thigh leaf 02 to thigh leaf 01. I'll do the same on the right leg. And then I will parent spine 01 leaf and thigh leaf 01. So those 3 attachment points, I will all parent them to pelvis leaf because I didn't specify, but I also had a leaf joint on the pelvis, just like I had for the spine. So basically I have this entire hierarchy where things are parented in series. So like this, if I go with page up through the hierarchy. So that's exactly the hierarchy we don't want to export in engine, but it's a skinning friendly hierarchy, let's say. It's more traditional. The important thing is obviously to select just the joints you care about when starting your skin. So in the outliner, I will carefully select the bones that I'm interested in. So starting with pelvis leaf, I will right click, select hierarchy, and press F in the outliner to highlight all the joints. Okay, so I pretty much want all of them except the upper arm and lower arm that I left in here. Actually, this should be a child of clavicle here as well. Okay, so sorry, one more time. So selecting all that. So I have the ball joints, feet, the calf leaf, the thigh leaves, the head and neck leaves, the hand, the lower arm leaves, the upper arm leaves. But I want to leave upper arm and lower arm out of the equation because they are like the parent joints. You know, all the skin weight should come from the leaf joints. For clavicle, I didn't make leaf joints because I have no intention to scale the clavicle area, but if you intend to, then same thing, you want to have a clavicle leaf joint and use it for skinning. Okay, so usually you want to do a create set quick selection set to say like skin joints, so it's easier to just go back in case you want to, you know, apply your skinning. Maybe you have to remove it if the first settings aren't the right ones. And then we would go to rigging, skin, bind skin, and here make sure to select selected joints and not joint hierarchy, because otherwise it will actually add upper arm and lower arm again. So here you really just want selected joints. And a little tip is when you apply the skinning to uncheck colorize skeleton, otherwise you get kind of random colors for each joint in Maya. That way, if like me, you put the leaf joints to a certain color, you're going to preserve that color, and it's probably easier to just continue by visualizing that way. And select your mesh and hit apply. This should give you a better head start than if you use the game engine friendly bone hierarchy. So from there, obviously, you can tweak your skin weights. So once you have your skin character, if you've used the skinning friendly temporary hierarchy, you want to convert it back to the game engine friendly hierarchy. So reparent the hands to lower arm, reparent each lower arm leaf to lower arm directly as siblings. Reparent the upper arm leaves as siblings. Okay, so you should have this upper arm with all the upper arm leaves as children, lower arm with all the lower arm leaves as children, plus the hand. We can close clavicle, then reparent head to the head hierarchy, which is underneath there for me. So I have the spine, 1, 2, 3, neck 1, 2, and head. So this one goes here, this one goes there, and so on. So for the spine, you should see every time spine 1, 2, 3, neck 1, 2, head, depending on how many spine and neck joints you have. And every time spine 0, 1 leaves, child of spine 0, 1, etc. Then you can fold the spine and look at the thighs and go ahead and reparent the foot directly to calf right, calf left, and then the calf leaves to the calf respectively, right and left. And the thigh leaves to the thigh. Okay, so we went back to our original hierarchy, and in the viewport you should see more or less this. Here I made a little mistake. I left the clavicles attached to spine 03, so make sure to reparent the clavicles to spine 03, the non-leaf joint, or spine 04, spine 02, depending on how many spine bones you have. So with the color and the children link, you should be able to quickly see if you forgot anything, because all your leaf joints should appear as standalone joints like that without any parent link. and if you shift them around, you should see the purple link from the default colored joints. So it's going to allow us to do, this sort of thing where we can scale that without affecting directly the scale of the next bone, and that's going to allow us to non-uniformly scale the joints without influencing the rest of the mesh. Another thing you can do to verify your rig is correct is selecting the parented joints, so here in purple, the ones that are within the hierarchy, and move them in Maya with pairs of children, and nothing should happen on screen. Like no vertex from the mesh should be influenced by those parent joints, because normally only the leaf joints influence the mesh. With the exception for me of the clavicles, I didn't use a scale joint for those, a leaf joint, and the hands because they are the end of the limb and I don't have the intention of scaling them, and the feet. For the rest of the hierarchy, only the leaf joints influence the mesh. Very important. And then you can select your entire hierarchy and your mesh and export it as an FBX to send it to MotionBuilder. The next step is to open the FBX you've exported from Maya, also known as the skeletal mesh that you could import in Unreal, into MotionBuilder, and then do the regular human HIK characterization. I have other videos covering that, so I won't focus on this aspect here. But just as a little summary, the first take that came with your import, you want to rename as a pose. This can just be one frame long. You want to go to the schematic view. So here I'm pressing Ctrl+2 to have two viewports, and do Ctrl+W to go to schematic, and a space right mouse button to select the entire hierarchy, and key on that. So I'm going to add, without story mode, I'm going to add a key here with the key button or the S button on your keyboard if you're using Maya shortcuts. And then duplicate that take and name it T-pose. So I'm going to actually make the joints a little bigger so we can see them more easily. And I'm going to select the leaf joints and make them a different color like we had in Maya, so it's easier to read. So selecting everyone here, I'm going to make them something like blue, like that, make them a little bigger. To put the character in T-pose, obviously you want to rotate first the clavicle, then the upper arm, not the leaf joints. And once you've rotated your arms and legs to be in a perfect T-pose and potentially fingers, don't forget to select all the joints again and key again to restore that pose, so you can go back and forth between the A pose and the T pose. Here I also merged the root control scene that is available on Google Drive, just to have that root control, which I like using, and a couple constraints to do like master relation, import modes, that kind of stuff. But that's not mandatory if you don't want to use that and you have your own setup. So I'm quickly just gonna go ahead and put the root joint into the root bone to control constraint and the control to bone constraint. Snap and lock both. That's all there is for that. Let me do auto arrange in schematic view and parent my root to skeleton, so that those are nodes that came with my template scene. Let me parent the mesh to models here, so it's all grouped. So let's look at the characterization for this little guy. For that, we're gonna stay on the T-pose, take, and here go to define skeleton. So which bones do you want to put in here? You don't want to put any leaf joint, only the main parent joints. So for assigning the joints, we're going to choose pelvis here. We're going to choose spine 01. spine 2, spine 3. Maybe you have more or less spine joints. Neck, we're going to choose neck 1, neck 2, and head. For the clavicle, I'm going to choose clavicle left here. Then upper arm, lower arm, and hand. So no lift joint whatsoever, not even in like the twist human HIK rolls. I never use those, to be honest. Here it gives me an orange warning, so maybe it did something wrong. Let me check. Upper arm left, clavicle left is good. Lower arm left, hand left. Don't know why it's not happy. It is perfectly parallel to the floor, except, oh no, I forgot to rotate my lower arm here. So 0, 0, minus 180. Then I might have to fix the hand. 0, 0, 180. There we go. Now it's happy, so I want to key that again. T-pose, key. I selected the entire arm hike. Okay, so no orange sign, we're good. Let's continue on the legs. I have thigh left here. So thigh, calf, and foot. And here I have a ball joint, so I'm going to select the toe base here for the ball joint. So make sure you have everything correct on your fingers. If you have fingers, the ball joints, sometimes it doesn't mirror. Yeah, actually here you see it didn't fill up the right toe base automatically. So I need to make sure I select that. Once you're done, you can lock the definition, biped or quadruped, depends on what you do, and bake to control rig, create HIK, then go to the A pose take, go back to no source, so skeleton source, and bake to control rig. And after that, the only thing I do on a simple character like that is just go to characters, properties, roll, inline, and zero out the values on the knees, and potentially rename. So we have our HIK rig ready. So far it behaves like a regular rig, and you might wonder, how are we gonna be able to make it squash and stretch? Because if we're in full body or body part or selection mode, but with HIK blend translation and rotation on, and we manipulate the HIK hand effector, we're not able to pull that effector beyond the length of the arm or the leg, right? MotionBuilder's HIK rig automatically keeps the hand HIK effector on, let's say, the joint, and we're not able to break that. But actually, if you select an FK control, so either the forearm or the hand itself, so the hand is a little hidden inside the HIK effector, but you can either hide the HIK effectors with this icon or go in the schematic view and select the hand right there, and potentially in properties make it bigger, like this, for instance. So if you select that hand and we look at the translation value here, in selection mode, you could actually translate that. Let me turn off HIK blend translation rotation on the HIK and select the hand. Of course, you can also select it here in the picker. So if I play around with this translation, you can see my limb is getting longer, like that. So in body part, MotionBuilder locks the translation of your FK limbs, but technically it is something you can manipulate in selection mode, right? I can even just grab it like that and move it around and break the translation. So we have what we need. It's just not automatically available. So all we have to do is to find an automated way to elongate the limbs. But we also need an object that we can freely move around, because again, MotionBuilder locks the HIK here, For that, we're going to use an auxiliary effector. So right click on your hand IK and create auxiliary effector. And with this, we're able to put the effector farther than what the IK effector allows us. And we are going to use a relation constraint to do some math, so that if we consider the original distance between the shoulder and the hand, let's say that's like length 1, we're going to compare the current distance between the effector and the shoulder. So if the effector is like, let's say, farther than that original distance, so here we have, let's say, actual length, so AL, for example, based on the current distance, let's say at runtime, so distance between shoulder and auxiliary effector, we're going to proportionally scale up the upper arm and the forearm. So we're going to see that the upper arm is a certain portion of L1, so let's say that's like L2, and the lower arm is another portion of that. So we're going to scale both of these proportionally so that they keep the same ratio between one another. Before we dive into the relation constraint to automatically lengthen the arm based on how far the auxiliary effector is, I want to customize a couple things on the auxiliary effector. First, the look. You can see here, because it's a cube, the regular hand IK effector is like inside of it, so it's hard to select both, apart from the picker, I mean. So you may want to change the look of the auxiliary effector and the properties, marker settings, look, change that for hard cross, for example, which you can increase the size of. Secondly, you want to make the auxiliary effector part of a character extension so it can be keyed together with the rest of the character when using full body keying, for example. That's something I've showed in other videos, but doesn't hurt to look at it again. So under your character, which I called mine Num Num, that's just what this model inspires me, you can right click create character extension, which appear here. I like renaming it to just name of the character underscore X underscore maybe left hand effector or something like that. I'll just call it left hand actually. And I'll just grab my effector and drag and drop it into here by holding X, click and hold drag from anywhere in the viewport and bring that object over there. And you may want to specify a reference object. For example, in this case, I might take the clavicle left as a reference. Okay. Then I want to be able to automatically drive the arm with the effector or have the effector be driven by the regular arm by having a kind of switch. So I'll make a parent-child constraint, call it parent auxiliary effector to left hand, for example. I'm gonna put the auxiliary effector as the constraint object and the hand IK effector, so the red sphere, as the parent. I'll zero it out so it's a constraint without any offset, zero offset. So currently I cannot move my effector anymore, but I can take the IK effector, and when it moves around, the auxiliary effector follows. That way I'll be able to, bake whatever animation I have before maybe switching to auxiliary effector mode and maybe animate all this in world space or whatever. The advantage of having this, that at the moment I benefit from all the pinning and the IK blend, either rotation or translation, from human IK automatically. So we're not done here. I want to make the weight of that constraint animatable, and in some hidden constraint, which I like to put in like a don't touch folder. So all these folders came with the root control scene that I merged in, which is available on Google Drive. So I'll go to base relation, for example, and I'll say the parent auxiliary effector to left-hand constraint will be here as a receiver, together with the auxiliary effector itself, of which I will make the HIK blend translation and rotation animatable, so I can drag and drop it in here as a receiver as well and drive those automatically. So I'll make a property on the auxiliary effector, for example. So editor, here, custom properties, with the auxiliary effector selected, I'll add a bool and I'll call it auxiliary effector on, for example. Oh, I think I added two. Okay. Auxiliary effector on, so I see the property here. If I just want to animate it through the timeline, I can leave it as is, but I like just controlling that from the master relation. So I will make the boolean animatable, but then I will lock that property. We can see it appears here now. So in the master relation, I just want to summon that object as well as a receiver. And I want to right click here to just toggle that from here. It's kind of my base of operation when I animate. I will just do hide unconnected to hide the other properties. Okay, so this is where it's receiving the value from, but again, you can unlock it and just toggle it here throughout the timeline. If you unlock it over there, you want to do right click remove value, so it's not overridden. So now I can actually control it. And back into our base relation, I'm going to call the same object again as a sender. So I'm going to use that boolean to drive the weight of my constraint, where the auxiliary effector is constrained to the left hand, and the HIK blend rotation translation. So for that, I'm just going to use a number node if condition, then A or else B. So if the boolean is true, plug that into condition. I can already right click hide unconnected here, keep it clean. If the condition is valid, we want 100% or 0%, and I'm gonna duplicate that node and do the other way around, 0, 100, because if the auxiliary effector on mode is on, well, a bit repetitive, but if the boolean is on, I want the constraint where the auxiliary effector follows the left hand to be off. So if this is on, we want to choose a 0% weight for that constraint, otherwise it's 100. But for the HIK blend rotation translation, if it's the opposite, we want those to be at 100% if the condition is true. So we can just plug this. So I have two nodes, kind of reverse, and that way, you know, I just have this like that, and if I toggle this here, now the effector is driving the hand. And of course, we see that we're back at the original situation where we will want the arm to reach the effector if it's beyond the original length of the limb. Okay, so just to make that kind of invisible, I'll put this constraint into the driven constraint under the don't touch folder. So that way I just have it over there as a toggle, and it's much simpler user experience. Finally, while being on the A pose here, I'll just key that object so I can key in full body, for example. Now I get a red key rather than a green key, which means not every object of the character is keyed. And I'll do the same on the T pose, just to have, you know, the position of the auxiliary effector stored somewhere. Now let's finally dive into the math to automatically lengthen the arm so it reaches the auxiliary effector when it's out of reach. So I will enable my auxiliary effector, and on this A pose take, or maybe a new take if you prefer, here I'll just make like 10 frames, and I will, on the last frame, pull that out like this and just key that object. So that way I have the arm kind of reaching out, and actually I'll put that key on frame 5, and on frame 10 I will put it back here just to verify that when I'm in range I don't get the lengthening that we will apply when out of reach. I just don't want that when we are within reach. Okay? So we need to measure the length of that arm, and we need to measure the distance between the shoulder and the auxiliary effector when it's out like this. So we'll start with a relation constraint. I'll call it like stretching, for example. Maybe specify left arm if you have another one for the right arm and the legs and whatever. So to measure the length of the upper arm, you simply need to get the local translation of the forearm. And to get the length of the forearm, you just need to get the local translation of the hand. But we are actually going to affect the length of these two parts automatically when we lengthen the reach of the hand. So I'm emulating that by just moving the translation property here. So we can't just directly get the translation of these objects because we will actually affect this translation. So we can't have the input be the output at the same time. So I'm simply gonna get the length by creating another object. I mean, technically you could also just like look at the value here on the A pose and enter that value manually. But you know, if you don't want to bother typing in those numbers, you can simply create a null, place it there on the elbow with hold X and hold drag and drop, okay, and parent it to the upper arm. So by default, without any squash and stretch, the translation of that object corresponds to the local translation of the forearm. And I'm going to do the same for the hand. Place it there on the hand and parent it to the forearm. We would probably want to rename those nulls, so I can maybe call it helper lower arm or forearm left and helper hand left, something like that. If you want to, you could also, in viewer options, disable the transformation. So once you've placed those objects on the hand and elbow, you can't move them around anymore as a safety. So in my relation constraint, I'm going to bring those two objects in as senders, and I'm going to right click, select local transformation. I then want to know the distance between the shoulder and the auxiliary effector. So I'm going to grab either the FK shoulder or the HIK effector. That's kind of the same result. Sender, and the auxiliary effector, sender. Under vector, I'm going to get the node distance to know the distance between two positions. I'll plug the translation, which is the world position of the shoulder, as one input, and the world position, so the translation, auxiliary effector, as the second one. And I will want to do a sum of the length of the upper arm and the forearm and compare that with the distance between the auxiliary effector and the shoulder. So here I will simply do an add this one plus that one. So that gives me the full length of the arm in bind pose. So it's not the distance between the shoulder and the hand in bind pose, because that would give me this distance there. Okay, because I don't know if you see, but my arm has a slight bend in my bind pose here. Maybe your character has even more. Maybe he's like a little bit like this, right? So we're comparing the addition of this distance plus that distance. Okay, we're comparing that with the line I drew in red, which here is because I have an angle on the elbow. The red distance is actually shorter than the sum of the upper arm and the forearm, so there's no stretching that needs to be applied. But if I go a few frames further, when my auxiliary effector gets out of range, the red distance now is bigger than the sum of the upper arm and the lower arm. So I'm simply going to do a divide, number divide. So we need two numbers in here, float numbers, so the distance here between two translations is already a number, so we can plug that in here. But here the sum of the two vectors is still a vector. So we need to convert that to a number by using the length. So we have the sum of two vectors, and then what is the length of this vector plus that vector. That gives us a number that we can plug into the divide node. So I propose we plug this number into something just so we can see the value. It's kind of like the equivalent of a print string in code, for example. So I'll just grab like any object. You could make just another null for that, or maybe I'll just grab this null here, one of the helpers, just use it as a receiver, and maybe I'll just grab like the visibility, for example. This is just temporary, just so I can plug that in here, and that way I can right click and do show all values. Okay, if this is plugged nowhere, it won't show anything, that's why. But we're obviously not trying to drive the visibility of that helper, that's like completely useless. It's just to be able to print that number. So you can see when I'm in reach, and in fact when I'm in bind pose, on the A pose, the value is close to 1. Well, that's actually because my arm is almost stretched exactly. You know, I have just a slight angle, so the value is close to 1. If your arm is more bent like this in your bind pose, the value should be below 1. If I go to the T pose, just to compare, you know, the auxiliary effector is exactly at the maximum possible stretch without applying extra lengthening. So the value is exactly 1 on my T pose. And when I go beyond the range, like here, the value goes above 1. So to see how this number affects our arms, because so far it's not doing anything, we can already plug the FK controls as receivers. So the forearm and the hand FK effector. Remember the yellow controls from the hierarchy, not the HIK effectors, as receivers, and we'll work on their local transformation just like we were using local translation on the helper inputs. In fact, I'm going to need those one more time so I can duplicate those, Control C, Control V, and we're going to take the local translation of these and scale them by this number, the result of the divide. These are not the final maths, but it's to see what it does. So I'm going to need that node a couple times. In the number, it's going to be the result of the divide, and in the vector, the local translation of our helpers. That way I don't have to, again, type in the values on the bind pose, here 29.48. I don't have to type that. It's automatically extracted from the helpers. Let's plug that in. So here when I go beyond, it looks more or less like what we would have. The arm is stretched out, but when I get closer, my arm is also straight and it's not bending. So that's because we only want to apply the result of that divide if the value is beyond 1. So if I stretch farther than my original length defined by the helpers. So what we can do is use a if condition node in the number section. If condition, then A else B. And what is going to be the condition? It's going to be if greater than. So greater or equal, in this case wouldn't do much of a difference. If this number is greater or equal 1, then we want to use the number in question. So if the condition is valid, we want to use A, so the number here. Otherwise, we can set a value of 1 directly. So we're not scaling the arms if the distance between the shoulder and the auxiliary effector is less than our original length. So let me plug that here as the new number and right-click disconnect. I can also delete the helper over there because now our value is plugged in actual nodes, so this is no longer useful. And let's do just a little bit of cleanup here. I can right-click, hide unconnected on all those nodes. Okay, so now if I go back to bind pose, everything looks correct. If I go beyond, I can see the output corresponds to the result of the divide. It's the same value because this boolean here says 1, so it's true. So we do pick the number A. But if I get closer in to the shoulder, the divide is no longer greater or equal to 1, so this is 0, so we pick this number of 1. And that number of 1 just leaves the upper arm and the forearm at their original length. So when we are close enough, the arm is just bending normally, and when we go beyond, it's stretching out like this. So we're starting to get the behavior that we're after. Now I propose we add a nice little feature where maybe you would want to artificially lengthen the arm. For example, if it's out of range like this and it stretches, maybe you want to extend the length to make it longer to regain a little bit of bending. Or vice versa, if we're shorter, maybe you want to reduce the length of the arm to make it so it has a tiny arm like this that doesn't bend. You know, just if you want to have more control over the cartoonishness, cartoonism, I'm not sure, of your animation. For that, let's add a property on our auxiliary effector. Properties, editor, custom properties. And this time, instead of adding a boolean like we did for the auxiliary effector on toggle, we're going to add a number. Let me call that length multiplier, maybe. And since it's going to be a multiplier, we don't want it to be less than 0. In fact, we don't want it to be exactly 0 because that would make the length of the arm just, you know, inexistent. So maybe we want to have like 0.01 as a minimum. Well, here I'll just assume animators will be careful, so I'll just leave it at 0. I mean, this is like 0.01 centimeters, so it's like 1/10 of a millimeter, so you can also do that if you want. I don't know about the maximum value, maybe just 10 or 5, something reasonable, because that will affect, you know, the slider here. So if you leave 100, like the slider will be covering too much range and it's not going to be super user friendly. I suggest we set it to 1 because it's going to be a multiplier. So we want to bring in our relation constraint as a sender. I could have copied the node I have here as well, from which we want to use the length multiplier. Here it doesn't appear because I didn't set it to animatable. Now it shows up here. So we're gonna multiply some values with it, so we can already choose from the number drop down the multiply node, length multiplier. Now I can shrink that. Okay, and we're going to use that to multiply the length that the system is getting from our helpers. So we're kind of tricking the system a bit. And we're going to do that one more time to scale the input so that the FK controls also get multiplied by this. So here, getting this number, plug it here and plug it there. Just to reassure you, I didn't come up with this quick. I tried many different things to get it to work before recording. So Now, when we are in bind pose, I can increase this value and it's gonna lengthen our original translation. And the stretching multiplier that we have here, the division, it still works the same. So that length stays the same if I'm within that new range, but if I go beyond the range that I multiply by 40%, I get the same behavior as before. I get a straight arm that gets longer as we go further from our newly calculated range. And it works also with a value below 1. So, for example, 60%. So in bind pose, now if I go below my original bind pose, the arm is still stretched because we're considering that its base length is smaller than before. And it'll start bending when I'm closer to the shoulder like this. So here we're starting to see some artifacts, and those are due to the leaf joints, which we haven't touched so far. So if I go back to the bind pose like this, you can see the leaf joints are spread throughout the limb, and when I get closer, we realize that these leaf joints here don't get proportionally closer to the shoulder. Same for the ones along the forearm. The only one that gets affected is this one because it's directly on the elbow. So we're gonna have to apply the same proportional change to those leaf joints. But yeah, I think the scale multiplier, the length multiplier, is a nice add-on because you can kind of force those kind of goofy deformations and make it your own. Okay, so we want to add the leaf joints into the mix so that either when I stretch out or when I compress the arm with the length multiplier, they should spread out proportionally along the arm. Here we can clearly see that they're all stacked up at their original length close to the elbow or to the shoulder. It's not super visible, like we don't realize there's an artifact until we look at the geometry. Like this, you can see that those polygons here, the edge loops, are spread out more than they are on this part here. It's going to be very similar to what we are already doing to the forearm and the hands. We are going to use the multiplier and scale the local translation by that number. So let's add all the leaf joints as receivers. I'm going to select them in the schematic view in a certain order. So upper arm 1, 2, 3, and then lower arm 1, 2, 3. And use those as receivers. So I could create helpers like I've done for the lower arm and the hands. So nulls that I would parent to the same parent, lower arm for example, and align to one of the leaf joints and use that value. Well, I'll do it on like leaf 02 here because leaf 01 has no translation since it's on the elbow. So leaf 02, just to get that number without having to type it in manually and never touch that null again. I'm just going to show you the other way, which is typing in manually, because the advantage of doing that is it keeps the number of nodes a little smaller. So after all, why not? I don't have that many leaf joints anyway. So I'm going to grab here the scale nodes. I'm going to unplug the vector and just do set value, right click set value. So I'm hard coding the value rather than reading it from an object. I'm going to duplicate that node several times before changing the value. In fact, I don't need that for leaf 01, upper arm, lower arm, because like I just said, they don't have any translation to scale, they just follow the upper arm and the lower arm. So I'm going to remove those scale nodes here. Just have to enter values for leaf 2 and 3 every time. So upper arm leaf 02, I have a value just on X. So I'm going to enter that here and plug that. make sure you're working with local translation, otherwise you'll get broken things like that. We're always working in local transform for this exercise. So just on this first bone, you can now see when I stretch out the arm, it follows proportionally along the upper arm. So let's just do that for the other 3 bones. Leave 0, 3, have this value. Lower arm leave 0, 2. And the last one. Okay, so that's the approach where you type in the numbers manually. Okay, so stretching out looks better. And if I get the arm closer in, around there, and I play with the length multiplier, I got rid of the artifacts we were seeing earlier because all the joints are being moved proportionally. Now, when I make the length longer like this, the problem is that I'm augmenting the volume because I'm increasing the length on one axis, let's say the length axis, but the thickness on the 2 other axes stays the same. So the total volume, the amount of flesh I have in the model, if you will, increases. And the principle of scratch and stretch is to counter what I gain in length by scaling the 2 other axes on the inverse. So we're going to be able to play around with the scaling of all these joints. So we need to invert this number that we're getting here. For that, I will use a number divide. The inverse is simply doing 1 divided by the number. And let's plug that into the scaling of all the bones just to see what happens. So we've seen that all my joints had a translation offset on x, right? X is my length axis, if you will, as we can see here with the local gizmo. So I don't want to scale on x. The scale on x should stay 1 the entire time. So I'm going to hard code here 1. I just want to affect the 2 other axes. All right. What I can do is just plug the result of that vector node in all these guys. And this time I will include the leaf 0, 1 for the lower arm and the upper arm. You can see as I increase the length, the bones are scaling down non-uniformly. So if I select one of those joints, we can see the sphere is being flattened, right? It still has its original X scale, but it's being compressed on Y and on Z. So that's very much why we made all these leaf joints separate leaves and not the parent of each other throughout the chain. Let's check how it looks when I'm compressing everything one more time. So now I'm getting squash because my arm is shorter and therefore they should regain some volume by gaining some scale on Y and Z. So we're getting squash here, a little muscular arm. One thing we can improve on this is making the scaling different for all the bones. I think we'll get a better look if we're making the middle of the arm a little thinner and reducing how much the first and last joints, so the joints close to the shoulder and the joints close to the hand, making them less affected by the scaling. So I'm going to implement that after the number to vector conversion by using a vector middle point node. There might be some easier way to do that, but I like using this. And I'm going to interpolate between a vector of 1, 1, 1, which is basically the original scale of the bone. So not getting affected by the invert we did here. And the fully multiplied vector. So like that. So basically, if the ratio number is at 0, we're getting the fully affected scale, so the non-uniform scale, here 1.7.7. And if the ratio is at 1, we're completely on this vector 1, 1, 1, which doesn't affect the scale. As an example, on the first node, you can see here between, well, I have to type in the number. So 0 is fully scaled, 1 is not scaled at all, and 0.1, 0.2, 0.3, any number in between will give me kind of an interpolation between the two. So I can duplicate that node several times, plug that into the scaling, and disconnecting the old cable every time. And now I can tune those numbers differently, the ratio I mean. So on the joints in the middle, for example, lower arm leaf 0.1, I'm going to put the ratio at 0. I want full-on scaling. Maybe on the next one I'll put like 0.20, and on the last one maybe 0.50. And same on the other side. 0.20, 0.10, 0.20, 0.40. So you can play around with values that make it more dramatic. For example, maybe I don't want the upper arm to be squashed at all, so I can keep that shape like this. I can even play around with negative values, which are going to interpolate below the first vector. That's a little dangerous, so be careful with that. But for example, with the elbow region here, if I want to be even more dramatic, I could go into like negative 0.2, negative 0.5. You see how it gets thinner. Just make sure that when you're in bind pose, this goes back to 1. Yeah, the scale is properly at 1, so that might be okay. That way you get more of this thin shape in the middle, but not that thin shape on the extremes. And I think that gives a more appealing look to the deformation. I just want to share a quick word about scaling. You might think that we could have approached this by scaling the upper arm and the forearm AFK controls on the length axis. So here, x-axis, I could have done this rather than working on the translation of the hand like we did here. Technically, yes, that kind of works in MotionBuilder. I mean, by default, you might get these artifacts because as I'm scaling the lower arm like this on X, that scale value is inherited by the hand. You see that value of 1.86, so that gives this weird stretch on the hand. There's a workaround. You can look at the properties of that object, and under transformation options, scale inheritance, you could change that to scale compensate, meaning it will keep its own world space scaling and not be affected by the parent. So technically that works here in the DCC package, but under the hood, if we look at the joints, the hand joint here is countering the scale of its parent. I mean, here we have the parent at 1.75, and yes, the hand keeps its value of 111 thanks to scale compensate, but a game engine will not like that, because it will not like that this bone has a certain value that is countering, compensating its parent. We want to avoid that for Unreal, for example. So that's why we use leaf joints spread out throughout the limb to handle this approach. The other advantages of having those leaf joints is that you could animate them. Here my translation is a little locked because I'm directly inputting onto the translation of these bones with the scaled value, but technically you could do that on nulls, and you could constrain the bones to the nulls, to be able to animate the offset. I mean, as an example, I can manipulate the leaf joint of the elbow because it doesn't have a translation input. You could animate those to have kind of noodle limbs. You could deform the limb to not be strict, two-segment limb like that, but you could make it kind of floppy if you need. So you have the bones already for that, so that's pretty cool. But yeah, we don't want to use scaling on these joints. That would not be good for a game engine. I know the relation constraint we've made can be a little intimidating, so I propose a little summary here in full screen of everything we've done. So we are getting the distance between the shoulder and the hand auxiliary effector. So it's kind of the actual distance at runtime, which can be shorter or longer than our reference distance, which we're getting here from those helpers we've placed on the elbow and hand in bind pose. We're getting the length of that sum. I'll get back to this right after. So we're dividing the actual distance by the reference distance, which give us the potential scale ratio. That scale ratio could be smaller than 1 if the auxiliary effector is within range here, right? If it's getting closer to the shoulder. So we're making sure that we're only using the number if it's greater or equal to 1. If it's lower than 1, we clamp it to a value of 1. So here and there we inject a length multiplier number, which the animator can control, just to force the deformation and make it more cartoony if you need to push it beyond the mathematically correct baseline. Then we use the results into a vector scale number. So we scale the reference transform we got from the helpers into the local translation of our forearm and hand. And we do the same on all the leaf joints of that limb by injecting the inverse of the multiplication. So we're counter scaling on the y and z axis. For you, maybe it's other axes, but for me, the x-axis is the length axis, right? So it's the axis on which each bone has an offset from its parent, and that's a pretty standard convention. Instead of using the divide here, you could have used the number invert node, which is exactly the same thing, 1 divided by a number. Additionally, we interpolate the resulting scale vector toward a vector of 1, 1, 1, which is the default scale for any object in 3D, so that we can cheat a little bit and make certain bones be more affected by the squash and stretch, just to get a nice appealing shape. So if you need that for another limb, you would duplicate the relation constraint, obviously change the input, recreate some helpers that you would place on the correct bones in bind pose, potentially make a new length multiplier for your other auxiliary effector, right? You would need to create auxiliary effectors for the other hand and for the feet. So for each auxiliary effector, you can have the length multiplier number, so it's independent. You would replace the input and output over there, and same for the leaf joints. Potentially for the legs, you might have less joints. In this example, I made it less detailed, so I have 3 leaf joints per segment on the arm because they're long, but my legs are shorter, so I just have 1 leaf joint, 2 if you count this one, 2 per segment. Okay, and you can hide that relation constraint in a folder. So I want to show quickly how to animate with that system. So by default, if you have the auxiliary effector on in your master relation or directly on the property, if you kept that unlocked, you will get the hand behaving in world space, which is maybe not the most comfortable if you're trying to do, let's say, a little walk cycle where that arm might be swinging around freely. So let's have some up and downs like this on the hips. And let me toggle this off. Okay, so with this off, the auxiliary effector is constrained to the hand, and therefore I benefit from all the human IK options like IK blend, translation or rotation if I need that arm to be a little more stable. So I could swing that around if I want, like this, and animate it any way I like. IK blend right on the shoulder as well. So it's all behaving like I'm used to. Okay. And even without the auxiliary effector on, I can play around with the length multiplier already. I could make the arm longer artificially like that if I need to, while being in IK effector mode rather than auxiliary effector mode. So that's interesting. Once you're done, if you need to go back to behavior where maybe the hand is planted on the floor and you want it to reach beyond its limit, as usual, you could bake your entire limb. If I select the auxiliary effector, you can see it also got baked because technically that auxiliary effector is part of this body part, even though it's also part of its own extension. So now if I activate this, I have exactly the same animation on screen, but the hand now behaves in world space. It follows the effector. So after switching to the auxiliary effector mode, make sure you don't leave any IK blend, translation, and rotation on the hand effector. Otherwise, the regular effector and the auxiliary effector will fight over the control of the limb, as you can see here. So if I try to drive with the auxiliary effector, it's not completely reaching that. You get a little offsets at some point. So no IK blend, translation, or rotation. And now I can edit the animation via the auxiliary effector. So if I delete some keys, for example, and I put it down on the ground like this, out of range, I see I'm getting the effect of the stretching. So we see our quiescent stretch in action, and the character could keep doing things like getting away from the hand, like so. And we can play around with our length multiplier like this. Of course, you can use layers to edit your animation, and I can bake all of that back to body part or full body and go back to turning off the auxiliary effector mode to go back to FK. Well, I mean FK, but just human IK mode, basically, where you can use the pinning and the IK blend as usual. Finally, I want to show how to do the same system on the spine. And you have two main approach here. You could create an auxiliary effector, just like we did for the arm. I have a constraint where it's potentially baked onto the chest effector, and use a similar relation constraint to calculate the sum of the length of each spine bone, and then compare the distance between the spine effector to the hips effector, maybe, or the FK pelvis, which is there. The hips, they're not necessarily where the IK hips are, because as a reminder, when MotionBuilder creates the human IK, it puts the hips effector, the IK hips effector, between the thighs, but maybe your actual pelvis bone is not exactly between the thighs, so maybe it's a little higher. So if you're using the technique where you place some nulls, I would recommend placing a null here on the first spine control and on each one of them, and then one last null on the chest HIK Effector, which is the sphere we see here as a see-through. So you have the position of that object. So you can calculate the sum of the local translation of each of these nulls, like this. So each null would be parented to the bone from before. So this one would be parented here, this one would be parented there, and so on. And the last one would be parented to the last spine control. So you get the local translation every time. And that's the sum, and that's your reference length. And then you use that as the divider of the distance between the auxiliary effector to the pelvis FK control, not the IK pelvis control. That's the best setup for this. And then you would scale the translation of all those joints and counter-scale the leaf joints. So that's one possibility. It's very similar to the approach I've shown on the arm. But there's a little trick that you might not be aware of. If you go to Character, Properties, if you change the character solver to HIK, whichever year, I think they should all work, from MB, which is MotionBuilder character solver, you get these options that pop up, stretch. And you can see for each spine and neck bone, you can increase the limits. They're by default at plus minus 10 from 100, so 90, 110 for each. So you can expand that. It's kind of your limits, right? So I don't know, I'm just gonna make it random. You would probably enter like proper numbers. Okay, and let's see. It's not doing anything just yet. If I'm in translation rotation either, I think you need to use these numbers to scale. Okay, those are your limits, but they only enable if those values are different than 0. So if we put it all the way at 100%, you see now when I manipulate, the length of the spine joint is automatically free. So it's kind of different from our original problem, which was that if you manipulate the HIK Effector, the arms are not stretchable, right? It's kind of weird that they never added that option for the arms, because it would have made the first part of this video obsolete and we could have just play around with this automatically. But anyway, it's available for the spine and the neck, at least out of the box like that. So you see my neck is a little limited based on those numbers, right? I could open it up even more if I want. And maybe you can decide that you want potentially more stretch on neck 1, but not the head. So you can play around with this, what works best for your character. The only disadvantage of that technique is that you lose the MB solver. And as a reminder, you need to be in MB solver for the modifier mirror animation option to work. I invite you to watch the video about using that option if you're not familiar with it. But yeah, I think technically you could still, work in HIK, then bake all your controls, making sure you bake the translation as well. If you need to, you can do it with selection mode, TR, and then doing plot all. And then you could always move back to MB if you need to do a mirror. So that's a possibility. Obviously here we're increasing the volume of our spine because we're not counter scaling. So you would still need to do a little bit of setup where you're calculating the distance and counter scaling the leaf joints proportionally on Y and Z to get this kind of volume preservation. I didn't record the whole process for setting up the spine, but here's the result. I can move around the chest thanks to the character properties, HIK solver, and stretch options. And I'm controlling the scale of the leaf joints thanks to a series of nulls that I've placed on spine 1, 2, 3, and the chest HIK Effector. I inserted those nulls inside the FK hierarchy. So in a relation constraint for the spine, which I duplicated from the arm, I have the measurement between the hips FK effector, which is here, and the chest HIK effector. So the distance between those two translations divided by the sum of all my nulls, local translation. So I use a sum 10 vectors to do the addition of more than 2 vectors. I divide. You can see I didn't implement a length multiplier for this because the animator is free to just like drag the chest around like this, so I don't really see the necessity for that. Those math are still the same. We're clamping if it's below 1. And I don't have the part where I'm scaling the translation of the FK controls because that's already taken care of by the HIK solve. So I don't have this bit over there. And I'm just using the middle point to interpolate the resulting scale towards a value of 1, 1, 1, so that the non-uniform scaling of each bone is not exactly the same. So for me, where the character has kind of this little belly, I'm scaling a little bit less than in the middle of the spine where it's thinner. And I kept the last leaf join actually always at 1, 1, 1 because I have a bit of influences on the neck. So you can see if I was using squash and stretch here, I would get some artifacts here. So it's because my skinning is probably not the best. If your skinning is just affecting the region of the thorax and not the neck, maybe you can afford to have a little bit of non-uniform scale over there. That's just it. So you'll find this scene on Google Drive. This gives you some idea on how to make cartoony characters in MotionBuilder. Thank you very much for watching. Good luck, and as always, if you have any questions, feel free to reach out in the comments. Cheers!